We'll just continue with the recap of our learnings yesterday. So the first session was on quality. There are many things you understood from the first session, but what you should not forget is two things. One is quality is meeting your customers' requirements consistently. That's the working definition of quality. If you are able to fulfill your customer's expectation, and you can proudly say you have quality in your offerings. It may be a product or it may be a service, but your understanding on the customer segment is very, very important. Who are going to be your customers? Who are going to avail your products and services? And make sure you design a product and then, offer it, with the features that will fulfill the customer's requirement. That is the definition of quality. And you should be able to do it consistently. Not that, you develop the product and slowly, it dies. It shouldn't be like that. You should also be able to continuously upgrade it, because the customer requirement also keeps changing. You must keep an eye, and that's where the word comes, consistency. And there are various quality stalwarts who shared their viewpoint about quality. And one important thing is the Takuchi's viewpoint of quality. According to Takuchi, variation is a loss. Variation is a loss. The moment you deviate from the target, don't wait till your product goes outside the specification. Don't wait till your product the defect gets noticed by the customer. If the product goes beyond the specification limit, then that means you are allowing the customer to view the defect, isn't it? So when the customer detects a failure, it is considered an external failure. External failures are so dangerous, and your brand image will go down, and then there will be a lot of other consequences. So don't wait for your product to become defective in the hands of the customer. Rather, you can proactively detect the failure, and that's where you need to measure the variation. Your product is well inside the spec, but then also if the variations are too high, you must understand, you have the responsibility to control it. So how much is the variation, whether the variations are high, variations are low? How do you know? By using the statistical parameter, standard deviation. Once you know standard deviation, once you know the average, you can also identify the control limit. And that's where, we talked about control limit and specification limit. But ultimately, the Takuchi's viewpoint is variation itself is a loss. If you produce a product meeting the customer spec with low variation, and I produce a product meeting the customer spec with high variation, then whose quality is better? Your quality is better. Both of us are producing well within the spec, but then also you will be appreciated for the quality, for the simple reason that the variations are low. That means you are staying too close around the target. And the quality principles are always you should be customer focused. For example, today I am just talking to all of you. I should talk in such a way that all of you understand, isn't it? I might know several things, but if I talk everything and none of you are able to grasp the point, and that's not the meaning of quality. You should be customer focused, depending on the situation, depending on the receiver. And even the word which is better than the customer is stakeholder. Sometimes customer themselves do not know what do they want. Right? It's quite possible. Maybe some of you, while joining the black belt training program, do you know the requirements of a black belt? 100%? Definitely no, isn't it? You know that having a certificate will be helpful for your career growth. But who is a black belt and how one should be certified? There are certain other requirements. Everything have to be fulfilled, and then your certificate will really have the value, and then it will have the global acceptance, isn't it? So that means the word which is better than the customer is stakeholder. As far as the training is concerned, all the participants, you are the end user. You are also a stakeholder. The organization that is conducting the training program, that is also a stakeholder. The trainers who are involved in the training program, they are also stakeholder. The organization that is certifying you, they are also stakeholder. The organization you are working, where you are employed, that organization is also a stakeholder. Your family is also a stakeholder. The society is also a stakeholder. The quality of black belt we produce should fulfill the expectations of the stakeholders. Isn't it? If you are turning out to be a best black belt, then you alone will not be benefited. Your company will also be benefited. You will grow, your family will grow, and then this is the definition of quality. So we should learn to see the immediate customer. The immediate customer is nothing but one of the stakeholder. Right now, for me, you are all the customers. Some 10 people are listening to me. So you are the customer. Now I should talk in a way that you all 10 of you are comfortably understanding whatever I'm speaking. Then quality gets built gradually, and then eventually it will make you the top class. And the customer focus. Another thing is you should be process centric. Be devoted to the process, and rest assured the results will automatically happen. Results are important, right? We are every business focus on the result, but as professionals, as black belts, your focus should be on the process. Otherwise, what will happen? Knowingly, unknowingly, you will make your organization people centric, and that will not give you results in long run. If you are expecting results in long run, instead of making your organization a people centric one, you try to make it process centric. Your understanding on y equal to f of x is very, very important. Not only in the project, in all aspects, particularly when you are doing a project, your y is the pain metric you wanted to solve. Y is mathematically a dependent variable. And if you want to control the y, whether you want to reduce the y or you want to increase the y, you must first understand all the x variable. What are the x variable? The inputs that goes into the process. What are the x variable? The conditions under which the process is running. We call them the process parameter. If you know what are the process parameters, if you also know what are the process input, if you also find a way to control them, you will be able to control your y. If you control the y, optimize it to the desired value, the problem is solved. All the stakeholders will be happy. Your business results will start growing in the positive direction. So fundamentally, it is the y variable. Whenever the y variable deviates, all the stakeholders will be affected. It may be a defect in your product. It may be a defect in your product. That's a y variable. For example, we conduct the training program, and the pass percentage is a y variable. It's not that everybody joins, they immediately pass. They go through a training program, various inputs is happening. And then end of the training program, exam is conducted. If the pass percentage is close to 100%, all the stakeholders are happy. If the pass percentage is less than 50%, do you think many people will come to you? Your business will grow? Definitely no. Now, what is pass percentage? Pass percentage is a y variable. If you try to tweak the y variable directly, then that's not a legal business, right? You should work on the x to optimize your y. That's the legal business, right? And so most of the time we consider a variable as a y variable only, if it is dependent in nature. If it is not dependent in nature, it is a direct fix. Direct fix, is not a great, problem. Anybody can fix. You really don't require a black belt or a green belt to solve such problem. You can have simple Kaizen team, and then they can fix the problem. That means if the problem is known, solution also known, you really don't require methodologies like DMAC. You really don't require people like green belts and black belts. Consider using, the Six Sigma methodology involving a green belt and black belt only if the problem is complex. Only when the root cause of the problem are not known, solutions are not available, right? Under such situation, this methodology will definitely be helpful. So point is y is a dependent variable and x are the independent variable. Only by controlling the x, you will be able to control your y. And you need to be data driven. Why you need to be data driven? Then only you can be fact driven. You need to be data driven, then only you can be fact driven. Otherwise, you will be biased while taking the decision. Your friend will say something, your team leader will say something, your boss will say something, and your employee will say something, and then you will be biased, and then things will go in a messy way. So to avoid that, you need to be data driven. When you are data driven, it is also very important that you use a data which is credible and worthy. Credibility of data is important. Since because somebody has given the data, you don't have to believe everything, right? Don't believe the opinion, even don't believe the data. You should be very sure about the worthiness and credibility of the data. And in order to understand that, you should be able to calculate the measurement error as well as the sampling error in your data. If the measurement error and sampling error are under control, then whatever signal that is coming from your data are nothing but the facts, right? So you need to be data driven. That means you should be fact driven. And then maintaining a good relationship with all the stakeholders is very, very important, particularly with your supplier. Maintaining the good relationship doesn't mean that, you just, go for a party with all your supplier. No, that's not the point I'm, highlighting. Supplier relationship in the sense, make sure your supplier also deliver optimal quality. You know why? All the inputs your supplier are giving are the inputs to your process. If the input itself is not coming with an optimal quality, what will happen? The final output will not have the desired quality, and who is responsible for the final output? You are responsible, right? So quality should be looked at in a holistic way. Whole organization is responsible for the quality. Each and everyone in the organization's contribution is very, very important. Whatever is the role you are playing in your company, your role is very, very important for the end result, very, very important for the quality in your products and services. So this is what in essence you learned in session number 1, right? And then we moved on to session number 2, where we talked about the Six Sigma, Lean Six Sigma, and Lean, as well as DFSS. So what is a Six Sigma project? Defect reduction. Focus, if the project focus is on reducing the defect, then the project is Six Sigma. That means your focus is on improving the effectiveness. What is effectiveness? Delivering output meeting customers' requirements. If your product meets the customer requirement, you are very effective, right? And this is what Six Sigma is trying to achieve. And it will follow a methodology called DMAC. On the other hand, there is one more type of project where the focus is on eliminating waste. What is waste? The inefficiency. What is inefficiency? Either you overutilize a resource or you underutilize a resource. Both should be addressed, right? You have a recent equipment you purchased, which is worth 2 crore. That is used, only just for 2 to 3 hours in a month. Now the equipment is completely underutilized. That it's definitely a efficiency issue. That should also be addressed. If the company invests on a resource, then it should be utilized optimally. So this will be taken care by certain projects. Those projects are called lean projects. Both of them can follow the methodology called DMAC, define, measure, analyze, improve, and control. One more kind of project where in the same project, you may attack the effectiveness, you may also attack the efficiency. Such projects are called Lean Six Sigma project. Again, the methodology is DMAC, define, measure, analyze, improve, and control. Sometimes what happens, your focus may be on developing a new product, developing a new machine, or developing a new process, or developing a new course, right? So these are all examples of a DFSS project. Suppose say tomorrow we wanted to start a new program. You are already there in the market, you are known for your quality. Now it is very important that you develop new product with the best quality, because you are already a big brand. So if you are focusing on developing a new product with the best in class quality, with nothing but the Six Sigma quality, then your approach is called DFSS, Design for Six Sigma. The methodology DFSS will follow DMADV, and we will be covering certain tools of DMADV in the Black Belt program, but this will be covered exhaustively in the Master Black Belt program. All right, so there are two methodology, DMAC. Another thing is DMADV, and DMAC is for improving the quality of existing products. DMADV is the methodology for ensuring the quality of new products and new process. And in 1987, Six Sigma methodology was introduced by a company called Motorola. The contributors are mainly two people. One is Bill Smith. Another thing is Dr. Michael Harry, right? And Bill Smith is today known as father of Six Sigma. Today he is known as father of Six Sigma. It is Dr. Michael Harry. He popularized the Six Sigma later on. There are several thousand people in Motorola were trained on Six Sigma. In order to do that, a university was established. within Motorola University. And Motorola made a lot of success, right? Several $1 billion they saved, and the Six Sigma methodology spread across the world. Now everywhere you can see Six Sigma training programs happening. And why Michael Harry developed the belt levels and other? Because if you expect somebody to work on a methodology developed by a company, DMAC, he should be trained. If without training someone, if you expect results, it is highly impossible. So training is absolutely essential. And then belt levels, responsibilities, and skill levels, and knowledge levels, skill levels were defined, defined very specifically. The knowledge level also, that's where the syllabus also differs. Whether you expect your participant to just understand, or you expect your participants to apply, or you expect your participants to evaluate or create, and these are called the Bloom's taxonomy level, and these are all very well handled. And then as body knowledges were created, and then it was followed at Motorola University. And then when Motorola introduced the Six Sigma, it had only 4 steps, 4 phases: MAC, measure, analyze, improve, and control. Later, when General Electric adopted Six Sigma in 1995 under the leadership of Jack Welch, the MAC was converted into DMAC, because he thought that his team thought that defining the problem is much more important than straight away measuring it. For measuring something also you require certain knowledge. So you must first define the problem, and so MAC has become DMAC in 1995, and today it remains the same, right? And then coming to the belt level, black belt, and your responsibility is to see to that you solve the complex issues in your organization, the cross-functional issues, right? Any project where the complexity is more, complexity in the sense, the X variables are more, and X variables are invisible, and multiple departments are involved in the same problem. These are all called the complexity. When complexity increases, and definitely a black belt must lead the project, and the project duration generally will vary from 4 to 6 or 7 months, right? And such projects will be handled by black belt. And then quality is a result of meeting 3 requirements. One is customer requirement, another one is process requirement, and the third one is employee requirement. Never forget to understand all the 3 requirements. If you expect quality, you must first understand customer requirement, and then you should also understand process requirement, and then you should also understand your employee requirement. If you keep any one of the 3 uncomfortable, then quality will be a big question mark, right? You need to make sure you always think, considering all these 3 requirements, so that quality is always ensured. And then process parameter, y equal to f of x. When you wanted to understand the performance of any process, there are 2 things. One is effectiveness, another one is efficiency. What is effectiveness? Producing output without any defect. That is called effectiveness. Producing output without making any defects. That means that nothing but doing things right at the first time, right? And that is called effectiveness. And that is what we also call it Six Sigma project. We expect our process to produce the output always, as per the requirements of the customer, right? And then efficiency. Efficiency is, without any wasteful activities. Any work you are doing, you may think whatever you are doing is great, but if the customer thinks, what you are doing is a waste, then that should be classified as waste only. If the customer thinks what you are doing is a waste, then you must immediately understand what you are currently doing is waste. And that's how a lot of changes happened in the market. Whatever we practiced last 5 years before, and now we are not practicing, for the simple reason that customers started seeing your work as waste. So you must stop doing such work and then change it, and in a way that customer likes it, right? And so this is called inefficiency. If you do a work which in a way that customer do not like it, or then what you are doing is simply a wasteful activity, or you can call it, you can consider it as non-value adding activity, and you must reduce it. If possible, you must eliminate it. And this is what the philosophy behind lean. And Six Sigma, we call it Sigma level, 3 Sigma level, 4 Sigma level, 5 Sigma level, and 6 Sigma level, and so on. This is nothing but a measure of the capability of your process. The capability of your process in terms of its effectiveness. When I run this process several thousand times, is that all the several thousand outputs will meet the customer requirement? All the several thousand output meet the customer requirement, your process is very, very effective. No defects at all, right? And so Six Sigma is basically a measure of process capability. You can use it as a metric. You can use it as a methodology. You can use it as a management system, or you can use it as a philosophy, right? And this is how the 3.4 DPMO also came. Once you bring the capability to Six Sigma level, you are sure that the defects are limited to 3.4 DPMO. DPMO stands for defects per million opportunity. You can link this for a manufacturing scenario also, service scenario also. You should be able to define what is defect in your product. Your product may be a physical product or it may be a service. For example, in a training program, when I show you a slide with a lot of typo errors, that is also a defect, right? And likewise, you should be able to apply the terminologies properly. And now we moved on to the another session where you understood little about certain statistics, basic statistics. There are two statistical parameters you learned. One is average, another one is standard deviation. Average is nothing but central tendency, right? And standard deviation is a measure of variation in your data. Both are important. Central tendency is nothing but is a value that will indicate what is that your process is targeting. Where what your process should target? Your process should target the customer target. Whatever the customer is targeting, your process should target exactly that. If you want to shoot a particular point, you must hold a gun pointing the same point, isn't it? Then only if you release the bullet, it will hit. Same way, if the customer is targeting something, you have to make your process target exactly the same thing. Customer wants 100 mm dimension. Then you must design a process in a way that every product that is coming out of your process should have 100 mm, right? And this is what we are checking by using the statistical parameter average, right? Always, depending on the nature of data, nature of the process, there are three types of central tendency available: mean, median, and mode. Mean will be of great help in most of the time. And as we progress, you will also understand how the median and mode will also help you. Right. So mean will help you to understand the central tendency, whether your process is targeting the target or your process is off targeted. The answer comes by looking at the value of the average. Then standard deviation. Though the process is targeted on the target, when you run it multiple times, there is no guarantee that every time it will hit the target. So there will be variations. So this variation is captured or measured using another parameter called standard deviation. Again, there are three options: standard deviation, variance, and range. What is variance? Square of the standard deviation. What is range? The difference between the maximum and minimum. But most of the time we use standard deviation. So once the mean is known, standard deviation is known, the behavior of the process can be understood to a great extent. And then we talked about specification limit and then control limit. And the specification limits will generally be provided by the customer. Specification limit will generally be provided by the customer. Target plus or minus tolerance will take you to the specification limits. If you cross the specification limit, customer is definitely going to reject your products, right? And you will lose the business. And another thing is control limit. What is control limit? And how is your actually business process performing? Just a minute. So how is your business process performing with respect to the customer's expectation? You can understand that by collecting some data from the process and then calculating the control limit. First of all, central tendency. Central tendency will let you know whether process is targeting the customer requirement correctly or not. And then standard deviation will tell you what could be the extreme output, the nature of the extreme output. If you calculate upper control limit and lower control limit, then you understand the worst thing that is going to happen out of your process. If you can control the worst thing, if you make the worst thing acceptable by your customer, then everything is acceptable. That is why it is very important to know the control limit. Control limit is a point which will be at a distance of 3 sigma units from the central tendency. Right? Average plus 3 sigma will be upper control limit. Average minus 3 sigma will be lower control limit. And we also talked about warning limit. What is warning limit? 2 sigma limits. To know the point which is at a distance of 2 sigma units from the center is called a warning limit. And based on the normal distribution also we talk. When you collect any data from a business process and then visualize it using certain graph, maybe a histogram, when you visualize it, if it looks like a bell, then you can understand the process data is normally distributed. Why do we use the word normal? Most of the process will exhibit this kind of bell shape only. And that's why the distribution is given, a name, normal distribution. And it was introduced by a German mathematician called Friedrich Gauss, right? And that is very, very helpful. And that actually gave birth to the statistics. So according to normal distribution, now there are certain characteristics of a normal distribution. Your normal distribution curve, the bell-shaped curve, will be symmetrical at the center. And then 99.73% of the points which you have used, which you have collected, will certainly lie inside control limit. If the you calculated the control limit using a sample. Sample can help you to understand the characteristics of the population. If the sample is collected properly, then whatever characteristics you observe in the sample, will represent the characteristics of the population also. This is how you can predict, the output that are going to come out of your factory. You have not produced, the several thousand units as per the order of the customer. You only produced a small portion of it, maybe 100 units or 500 units you produced. But by studying those 100 units or 500 units, you can judge on the quality of the several million units you are going to produce. This is purely based on your knowledge on normal distribution, right? So 99.73% of the points are expected to be inside the control limit. 45% of the points are expected to be inside the warning limit. 68.27% of the points are expected to be inside 1 sigma limit, right? So these are certain properties of the normal distribution. And at any instant, if you are able to understand that your control limits are staying inside the specification limit, you can immediately conclude your process is capable. Control limits are inside the specification limit. You know how to locate control limit. Average plus 3 sigma. If you see the control limit inside the specification limit, be rest assured everything you produce will be accepted by the customer, right? So this is what we call it capability. So the capability is nothing but getting your control limit inside the specification limit. If you get your control limit inside the specification limit, you are playing the game of business very well. And if the control limit just touches the specification limit, you can conclude your process is just capable. That means you are sure that at least 99.73% of whatever you are going to produce will be accepted by the customer. In terms of sigma level, it is called 3 sigma process. However, the limitation is this judgment, this prediction is applicable only for short term. Why? In long term, process will automatically deteriorate, and then all your conclusions can differ from reality. So in order to make your conclusion approach the reality, you must understand about the deterioration, and so you will keep your capability always higher than what is just required. Just capable is not good enough, so we always go beyond. That is why the CP/CPK values are not fixed at 1. We always aim for either 1.33 or 1.67, because in the long run there will be deterioration of the process. So just capable process may not yield the desired result in a long term. And so we aim for higher capability. You can also think of making your process doubly capable. A doubly capable process is nothing but a 6 sigma process in which the yield will be 99.999666%. This 99.99966% is a long-term capability, is a long-term yield. It is under such situation, the defects will be limited to 3.4 dpmo. So ultimately, the process width is decided by the location of the control limit. The specification width is decided by the specification limits provided by the customer. What is very important for any business, any process, for any product or any services, the process width should be smaller compared to the specification width. And thereby you can comfortably bring your control limit inside the specification limit. And then finally, the last session, you discussed about the define phase. And only in order to ensure this happens, the control limit comes inside the specification limit, we are going to follow the DMAC methodology. Define. What is define? Properly understanding the problem. What is your problem? The Y variable. The Y variable is the problem. You need to understand everything about the Y variable. Since you have handled the Y variable badly, or you allowed the Y variable to deteriorate, your business is experiencing a lot of problems. Business issues, business consequences. Since Y variable is not at the desired level, business will be facing a lot of consequences. Your market share is going down, right? And your profit margins are not healthier. Lot of customer complaints are happening. So all these business consequences, which are nothing but the Z variable, generally will make the leaders in the organization to feel bad about the performance. And so projects are required. Why your market share is going down, why the defect levels are very high, and why the customer complaints are more, why your profit margins are low, because your product quality is not meeting the expectations of the customer. So what is that customer expect from your product? What are those characteristics? Is it dimension, or is it surface finish, or is it the strength of the material, or is it the time you take to deliver the product? And those are called critical to quality characteristics. Whatever customer looks at or expect in your product, each and every characteristics are called critical to quality characteristics. So one of the critical to quality characteristics is your Y variable. Since that Y variable is not at the desired level, the critical to business characteristics are under trouble. You call it the business consequences. So it's very important you identify the CTQs. And if the CTQ is in trouble, if there is a deterioration of your CTQ, and if that is a Y variable, then it is an opportunity for Six Sigma. If the CTQ is a Y variable, then it is an opportunity for Six Sigma. Otherwise, you can solve it by any other simple methodology. You don't have to bring it under the umbrella of Six Sigma and all the analysis. Since because you have so many tools, you don't have to, you should not try to use everything for each and every small task. When the CTQ is a Y variable, then it's an opportunity for Six Sigma. Then you need to proceed to understand the Y variable. Understanding the Y variable is the define phase. In my opinion, one is considered to have understood the Y variable if he can express the Y variable in the form of a number. The problem, whatever you wanted to solve, if you can express in the form of a number, then the define is done. A measurable, you have converted that problem into a very specific problem, and you converted the problem into a measurable one. Now the define is over, right? Now the define is over, and then you can create a project charter, beautiful charter, and then you can get it approved. And now when you are identifying project, what is most important is goal alignment. You are trying to solve a problem. Why? Because you think the problem is very, very important to you. But what is much more important is whatever problem you wanted to solve should be important to your organization also. If your organization preference is something, but your preference is something else, do you think your organization will support your project? Definitely no. So it's very important you understand the goal alignment, right? So that has to be checked, and that's where the quotient country matrix and the business scorecard will come and help you. And then goals can be of three types: organization goals, strategic goals, tactical goals, and then operational goals. Strategic goals are long-term in nature, requires 3 to 5 years of effort, and then they are called the strategic goals. On the other hand, tactical goals are annual goals. Tactical goals are annual goals, and the middle managers are responsible for it. But how, as an organization, how do you achieve your strategic goals? By achieving the tactical goals. As a middle manager, how will you achieve your annual goals? By dividing your annual goals into maybe a smaller version, smaller goal. Now they are called operational goals. These operational goals are nothing but improvement projects, and some of them are opportunities for Six Sigma, right? So Six Sigma projects are nothing but projects identified at the operational level. Now the project is identified from the down level. So this is called bottom up approach. You can identify projects from the bottom level. all the issues that are happening at the operational level can be considered as project. On the other hand, you can also identify projects from the top level, top-down approach. Most of the time, the top-down approach are like capacity expansion or developing new product. And so those projects will be DFSS. But if the organization really wants a DMAC project also, and if it is identified as a top-down approach, yes, that is also possible sometimes. And then you learn the tools like voice of customer, voice of business, and cost of poor quality, right? So voice of customer is the statements received from the stakeholders. The end user is definitely a customer, and your employees are also considered as internal customer. So if there is a pain experienced in any of the statement, that is an improvement opportunity. Similarly, voice of business is the voice of the leaders in the organization. For example, the inventory levels are very high. Cash conversion cycle is very high. Do you think the customer will talk about cash conversion cycle? Your customer will talk about inventory? No. But the leaders in the organization will definitely worry about these things because they know the consequence. If the cash conversion cycle is longer, then a huge investment will be blocked, isn't it? If the inventory levels are high, then huge investment will be blocked. So these are all certain pain statement you can understand from the language of the leaders in the organization. So this is called voice of business. You can identify projects looking at the voice of business. You can identify projects looking at the voice of the customer, whether you directly listen to them or you do a survey or you do an interview or you conduct a focus group discussion or you conduct a brainstorming meeting, it is up to you. Or you can also refer to the documents and try to understand the burning issues in the organization. So voice of customer is one source, you can identify project. Voice of customer is another source, you can identify project. Another source is cost of poor quality. Already there are failures happening and your company is burning the money. And it is estimated that organization simply burn away 20 to 45% of their revenue in the form of cost of poor quality. Cost of poor quality can either be external failure or can be internal failure. What is external failure? Customer detects the failure. A defective product is supplied to a customer and customer detects it. And now there will be a lot of consequences. There will be warranty claims. You have to replace the product and you have to provide service, and all these things are cost of poor quality. But on the other hand, internal failure is also cost of poor quality. What is internal failure? Customer is not detecting, but you yourself detect the failure. Your quality inspectors detect the failure. So if the failure is detected before, within the factory, it is called internal failure. If a failure is detected outside the factory or outside the organization, that is called external failure. If you poorly control the internal failure, then external failures will automatically increase. If you control the internal failures very effectively, external failures will become very, very rare, right? And that's the logic. So find a way to detect all the failures internally and then come out with a very good problem solving approach. Thereby you can prevent even the internal failures from happening. And then the tools, maybe the brainstorming can also be a good tool now to identify the project. You can call all the department heads and then the managers, and then you can allow them to represent their problem. Now you will have plenty of issues. If you allow people to talk about the problem which they are experiencing in the organization, I'm sure somebody can even go to the extent of crying, isn't it? So that many problems will be there. You need to create a platform where they can represent the problem. Now a list of projects will be available in your hand. This is called project hopper. You can now categorize the list of projects into different segments, maybe department wise, budget wise, duration wise, project complexity wise, whatever way you categorize, you will have projects filled in different buckets. And now the resulting table is now called an affinity diagram. So where now you have let's say a list of projects, 10 projects or 20 projects. Now which project you will implement first? You have about 10-20 projects. Now which is most important to you? There comes the next stage. Now that the project is identified, but now the challenge now is project selection. Select a project which is most important to the company. Select a project which can help the organization achieve the strategic goals, right? So the project goal should align with the strategic goals of the organization, the goal alignment, and also And also the team which is selecting the project should also have a fair idea about the process which is actually responsible for the failure. Where is the failure? The Y failure is happening at the Y variable. So you must identify the process which actually contains the Y variable. If you land up in a process which is not responsible for the failure, then all the energy and then time invested will go in vain. So that should not be the case. The team which is actually a combination of black belts and the project sponsor, generally they will be involved in selection of the project. So such people should have an idea about the organization's priority, should have an idea about the various processes that are going on in the organization, and then they must actually identify the project, and thereby implementation can become easier. So I think this is what you have in essence discussed throughout the day yesterday, right? So now we are at a stage where we really wanted to pick one project out of the entire list. You have a list of, let's say, 20 projects. Now, how will you prioritize? Which is most important to the organization, or which project when you present it will get quickly approved? So that is the goal now, which is called step number 2. So we are now going to have the next session, which will talk about project selection. How systematically you will prioritize the project. What kind of analytics you are going to bring in, what kind of visualization you are going to bring in, so that your boss, if he looks at your way of approach in prioritizing the project, will get impressed, and then straight away whichever project that appears in the first row will be approved, and then your project will be live, and you will go ahead with preparation of the complete plan of execution for the project, what we call it as project charter. So for that, we have Dr. RK, who will take you through certain tools which will help you to prioritize the list of projects you identified in step number 1. Yes, questions?